when I've created these things before, I've generally added them later because it just the follow-on wizard is a little bit more intuitive to use than is so here inside of this wizard. If you do want to click Add Now, though, you'll see that there are various settings here that are really defining how many ports are designated on this host. So 256 by default. Same thing if you hit the settings button up here. If you have any hosts that are incompatible for this version of the switch, you'll find them here, and it'll tell you why. Perhaps it's a host that's not at version 5, for example. So I'm going to add those hosts later and click Next and Finish. And so what you'll see is this new DV switch that gets created. Here it is right here. I have a DV port group, no VLAN that's currently assigned to it, and I have the DV switch over here on the other side. If I zoom out just a little bit, you can see pretty much about the same thing. See if I can minimize that. So here is the DV uplinks here on one side. Here's the port group on the other side. Just like we were talking about before, this is the same kind of left-right scenario that we were discussing before. So what we have to do at this point is effectively begin defining in the physical side of this switch. So what do we want to add in over here on this side in order to support the things on the other side? Now you have to be kind of careful here, especially if you already have an existing production environment up and running. As I mentioned, in our world today, in our little environment here today, we already have all of our network connections. They're already functioning, right? They're already virtual machines are making use of the existing standard switches. And so moving them into this DV switch situation is actually going to cause a bit of an outage for those virtual machines because, unfortunately, I only have a single connection for that standard switch's virtual machine port group. So if you have an existing environment, there are some migration sort of thinking, some migration activities you'll have to do to make sure you don't lose access while you do this. In the meantime, however, what we do want to do is actually get some of these different things up and running. Now, the first thing we can do is click over here to take a look at the DV uplinks. So these are again, the right-hand side of the equation and what different uplinks that we've configured in here. I have a name, I have a description here. You may intend to change the name here if you want to make it a little more useful for your uses. And I can also set in here some policy information as well. Same sort of stuff, promiscuous mode, MAC address changes, forged transmits, ingress and egress traffic shaping now, the VLAN that's set for this. Let me scroll that back up here. Here's the VLAN in terms of what VLAN type we're actually using. The teaming and failover settings. There's the failover order. And the resource allocation information, monitoring, and miscellaneous information. So these are all then defined further if I click down here to take a look at the specific settings here. And I'm not going to re-go over all this stuff with you again because all of this is essentially the same sorts of settings that you've seen before when we were taking a look at the standard switches. Now, what's different here, however, is this resource allocation, monitoring, and miscellaneous stuff. Now, what's different in what you see here is this resource allocation, monitoring, miscellaneous, and the advanced stuff in here. These are different because these are where you could actually identify a network resource pool, okay, and you could use networking configurations, right? So how many network resources are you using as a measurement for your allocation of resources, okay? Network I/O control is a mechanism that allows you to limit the virtual machine's use of its network